and welcome to my channel. Today I'm back with the fourth part of the Building SIEM with Open Source Tools series. In today's video, I will show you how to use the patterndb to parse the log messages. Parsing log messages is a critical component of any SIEM tool. Parsing allows us to identify and extract interesting data from the log for querying, indexing, investigation, pivoting, or alerting. And efficient and accurate log parsing is crucial to extract the true value of the logs and produce some meaningful uses. Therefore, a SIEM without a good log parsing tool may not be an ideal SIEM platform. If you have not watched my previous parts of this series, I highly recommend you to go back and start with my first video. Without further ado, let's jump in. Let's talk about and get a high-level overview of the patterndb and its various components and processes before getting into the actual hands-on configuration. The patterndb is a database of patterns that are expected to be matched. The db parser function processes the message content against the pattern database. The pattern databases are one or more XML files that contain rules that describe the pattern of the message. So each pattern database has a collection of rule sets in the XML format. The rule sets represent a collection of rules that are common to a set of program. The rules then actually contain the logic to identify, correlate, and modify similar messages. The pattern has the logic on how to match the messages. So basically, the patterndb file has rule sets, and then the rule sets have rules. The db parser function is used to actually load the pattern databases during the Syslog-ng startup. The next component I want to talk about is the pdb tool. Pdb tool comes in very handy to manage, create, and test the patterndb files. It can be used to merge multiple XML files into a single big pattern database file. It can also be used to test a parser against a log file to ensure the expected behavior before actually deploying the parser into production. The pdb tool can also be used to generate a parser template that can then be used as a starting point when creating new parsers. The next and very important component is the available pattern parsers. You can see the available pattern parsers in the slide, and it is also available in the Syslog-ng documentation for reference. I will include the URL in the description for your reference. First, let's take a look at the syntax of the pattern parser, and then I will briefly touch on all the available pattern parsers. As you can see in the slide, the pattern parser starts with a beginning @character, then has the type of the parser in uppercase. Then it has the optional name, and then the parameters of the parser, if any, and finally the closing @character. Therefore, the pattern parsers are enclosed between the @characters. Let's take a quick look at the examples in the right side of the slide. The simple parser simply has the string as the type of the parser enclosed between the @characters. The next example is the named parser, which has an additional macro name after the colon character. In a named parser, the value of the matched message will be assigned to the specified macro name in the name field. Another example is a named parser with parameter. This example has an additional parameter after the macro name, an asterisk in this case. The asterisk parameter passed to the parser tells the parser to accept asterisk as a valid sequence in this string. Otherwise, only alphanumeric characters without the white space are accepted. The final example we have here is a parser with the parameter but no name. In this case, the parser will be used to match the message but is not extracted into a macro. The macro field, as we can see, is left empty. Now that we understand the syntax of the pattern parsers, let's talk briefly about all the available pattern parsers. You can always reference the Syslog-ng documentation for additional explanation and examples. The first one we have in the list is the AnyString parser. It parses everything to the end of the message, and you can use it to collect everything that is not parsed specifically to a single macro. This can be very useful when building out new parser, creating a catch-all parser, or when you are debugging a new parser. Double parser is an absolute alias of the float parser and is used to parse the or match the floating point number that may contain a dot character. We have an email parser. This parser matches an email address. It can also take a set of characters to strip from the beginning and the end of the email address as a parameter. So you can use this to extract an email address between tags. For example, an angle bracket or a code. So you would pass the angle bracket or the code as the additional parameter to the email parser. Next one is the eString parameter. This parser has a required parameter that acts as a stop character. So this parser parses everything until it finds the stop character that was passed as an additional parameter. The float parser, like we talked earlier, is a floating point number or matches a floating point number that may contain a dot character. We have a hostname parser that can be used to parse a generic hostname. The hostname can contain alphanumeric characters, a hyphen, or a dot. The next parser we have is the QString parser. It can be used to parse a string between the quote characters specified as a parameter. You can also note that the quote characters can be different at the beginning and at the end. Another parser we have is the set parser. The set parser can be used to parse any combination of the specified characters until another character is found. For example, specifying a whitespace character parses any number of white spaces. It can also be used to process paddings. For example, if you have a log message that have whitespace padding after the username. The next parser we have is the string parser. The string parser matches a sequence of alphanumeric characters, not including any whitespace. Optionally, you can pass an additionally accepted characters as the parameter. Like if you remember in our previous example, we passed the asterisk as an additionally accepted character to this parser. Next parser is the IPv4 parser. As the name suggests, it parses an IPv4 IP address. The next is the IPv6, which is also self-explanatory. The other one we have is the IPv-any. So it parses any IP address. It can be IPv4 or it can be IPv6 address. The other one we have is the LL-adder, which actually parses a link layer address. Then we have the MAC-adder, which parses the MAC address, matches the MAC address of the standard format, which consists of the 6 groups of 2 hexadecimal digits separated by colons. The other parser we have is the NL string parser. This parser parses everything until the next new line character. If you want to be more precise, it will match anything until the next Unix style LF or the Windows style CRLF character. So for single line messages, the NL string is equivalent to the any string parser. For multi-line messages, NL string parses to the end of the current line, while the any string parses to the end of the message. So the NL string is really useful when parsing multi-line messages, for example, the Windows logs, which have a lot of new line characters. The next parser we have is the number. The number parser parses or matches a sequence of decimal numbers, 0 through 9. For example, 1 or 2 or 100 and so on. We have to note though that if the number starts with a 0x character, it is parsed as a hexadecimal number. The next and the last parser we have is the PCRE parser, and it uses the Perl compatible regular expressions to match a value. One thing I would like you to note here is that even though all these different parsers are available, the E string and the Q string are processed much faster than other parsers and are less CPU intensive. When you use the parsers like IPv4 or email, hostname, be careful on your CPU uses. Finally, let's take a quick look at the sample parser that I created before we get into the actual configuration of the patterndb parser. This is a parser that I created to parse the NTP-date cron message. As you can see in the sample parser, it starts with the patterndb tag that has the version and the publication date. Then we have the rule set tag with the name and ID. The patternize in the name tag is because I used the PDB tool to generate the template for this log message. After that, we have the rules tag, which has an individual rules, which in turn have the patterns. The patterns tag then have the pattern that actually match the messes. There's also an optional examples tag that can be used to keep an example messes that is supposed to be parsed by the patterns. It is good to keep an example within the rule set because that way, in future, you can reference the actual messes that you expected the particular pattern to parse. There are some sample patterndb parsers to help you get started on the Syslog-ng's GitHub, and I will show you the basics of how to create a parser with a basic log example to get you started. I will also put this URL in the description. If you end up creating a parser yourself, please comment and let me know. I would be excited to see the parser. I've also created a couple custom parser myself and will publish to my GitHub soon. Enough talk. Let's get into the real deal. I'm currently logged into the Syslog-ng server that we've been using for our previous videos. I'm in the etc Syslog-ng directory. Let me quickly do an ls-al here. I have some archived configs into the archived configuration. I've got the GLI2 cd.mmdb, which is the GUIP database from MaxMind. We will work on setting up the GUIP enrichment in our next video. For now, we will be focusing on the patterndb.d directory that we have here in order to create the parsers. Let's take a quick look at the Syslog-ng configuration file to understand where we're at with the configuration. So basically, we have the local source, system, and internal. We have the network source, which is the UDP and TCP. And then I additionally created a local file source so that I can simulate additional new log messages with the TMP input as a file input. So for this example, I will be putting in the logs into that file to simulate an incoming log. We then have the destination, which is the local destination, which is the var log messages, and we also have the messages-kv.log, which is the key value paired transformed log event. We then have the Elasticsearch as the destination. We've already talked about this destination in our previous videos, so I'm going to skip that. Then we have the actual log statement that combines all the sources to a destination. Spatially, like if we look at the log and then that has the destination, the Elasticsearch or the d_es as the Elasticsearch, that's the destination that we are really interested in, and we will be using that log statement for our parsers and all that stuff. Now, going back into the Kibana interface here, I have the Kibana interface here. I injected some SSH logs using the TMP input file, as you can see here. Now we can see that we have this log message here that says the accepted password for root from that IP address, port that, and SSH2 as the program, but we do not see that message being parsed out, which means that we will not be able to visualize or make meaningful use of the source IP address from which a user logged, the username who logged, and maybe the source port, which is not really a big deal, but the main things that we would be interested in this log message is the result, which is accepted for the password. So it says the password was accepted. Then the username, which is the root, and then the from address. Those are the main things that we would be interested in. So we'll go ahead and create a parser that will parse those things out, and we'll do the comparison of how the log looks like in the Kibana interface when we extract them out. I also wanted to point out that the Syslog-ng patterndb GitHub library has a variety of patterndb parsers already made. So we have the login PDB for the PAM database, the SSH, VMware style. So if you look at these are actually the XML files. The extension of the file does not really matter. It just, is there for notation, I guess. As you can see here, these are the patterns that need to be masked and all that stuff. We could just take this SSSD parser and be done with it, but I wanted to walk through the process of creating a custom parser if you needed to. The repo also has the sudo parser, the su parser, and then let me just real quick go back here. patterndb. It also has various applications like the bind, the name server, the citus, the IIS, the MSDNS, OpenSSH parser, the postfix mail server parser. There are other things also. So we have the Windows parser as well, which would have probably been the most complicated parser if we had to write on our own. What I really wanted to show you is that there are so many parsers out there already available. So you can, use them as a starting point, and then everyone has a different environment. So there will be times when you will require or you will need to create a custom parser, which is why we want to go through the process of creating one custom parser as an example so that you can do that in future when there is a need to. All right, it's too much talk. So we already looked at the log message here. Let me go back to this is the Syslog-ng that we are using. Like I said, I have the TMP input as that. Let me just take one single log message, and I'm going to say TMP parse or ssh.log. I'm going to paste that message there. Now we are going to use the PDB tool to create a starting point for us. If you remember, the syntax for the PDB tool is PDB tool, and then we pass the patternize command or the parameter, then support, we can say 2.5, that's the patterndb version, file equals tmp ssh.log. When we do this, it will generate a template for us to start. There you go. So here we can just copy this here, or we could have actually just did this, right? So let's say ssh.parse-parser.pdb or XML or txt, it doesn't really matter. Now let's go ahead and take a look at the ssh.parser.pdb. As you can see here, the pattern, we have one pattern that has the accepted password for root from blah, blah, blah. So it has the actual log message there. It just creates the format for us, and it does not really create the actual parser. Now we also have the example in there for the message that the pattern template was generated. So it's really helpful to start with the PDB tool template. Before we can actually start using the patterndb parser, we will have to instruct or configure Syslog-ng to use the patterndb parser. Let's first create and validate the parser using the PDB tool, and once we are ready, we will configure the Syslog-ng to use the newly created parser. We're looking at the ssh.parser.pdb file that was generated by the PDB tool. As you can see, it has the patterns, it has the example, it is well structured, so it's really good to start with the template generated by the PDB tool. As we can see here, we are just working on parsing a single message at this time. As an example, this is the line that we're interested in parsing out. So we want to parse this accepted, we want to parse the username here, and then we also want to parse the IP address from which the authentication had happened. In order to parse the accepted here, we will use our parser in the way we already discussed. Starts with the @ character. Then we are going to use the string because we want to stop matching as soon as we see the first white space. So we'll say string, and then we will parse this out to the ssh.result. You can name this anything. So this is the ssh.result is what I'm mapping this to, the value to. Then we're going to say, okay, as soon as you see the white space, stop. Now that we're using the white space in our pattern, we're going to remove this here. So now let's go ahead and test to see if we got somewhere. So we're going to say PDB tool match -f. So the log file, tmp.ssh.log, and then we're going to match against the ssh-parser.pdb. As we can see here, that the accepted word has been extracted into the ssh.result. That's a good first step. Now let's go back to our parser. Now we want to extract the username. It should be the same way. So because we're going to look for this string and match until we see a white space, we're going to use the same E string for this case as well. We can say map it to sss.username and until you see a white space. So let's go ahead and do that. And let's see if we get the username as well. So something didn't work right. Let's go back here. We need to remove the space from here because we use that inside the parser. There we go. So now we have the accepted extracted into the SSH result, but we also have the username extracted into the ssh.username field. Back to the parser here. We're now going to try and extract the IP address from the log message. We can do the same thing with the port. It's just going to be, say, the number, but we don't really have to for the source port. So for the IP address, we can simply use IPv any, if I remember it correctly, and we are going to parse it to ssh.source IP. We can change that to whatever we like, but I'm just going to do that. And because we're not using the space for this case, we're just going to leave the space there. Save it, and let's see if that worked. That did not work. So let's go back and see if I match the pattern here. So I've got the IPv0 because this is uppercase. And that should be it, honestly. Okay, there we go. So now we were able to extract the accepted, the username, and the source IP. So for this example, I think this is a good enough sample. So we'll go ahead and start using the ssh-parser.pdb with our Syslog-ng. So let's move that parser into the patterndb folder that we have here. There we go. Now we will configure the Syslog-ng, instruct it to use that parser. I'm going to edit the syslog-ng.conf file here. Now, like we talked earlier, we're going to use the patterndb or the db parser function to load the patterndbs. We'll go ahead and create. So after the source, it doesn't matter where you place this. We'll say parsers, and we'll say parser pattern_db. It's going to be this. Just like to finish doing the start and the close first so that I don't miss it. db-parser, we're gonna say file. Let me actually grab the path. Etsy syslog-ng patterndb ssh. Okay, so this is the full path. I like to specify the full path here. So we're gonna say here db parser file, and we're going to use that, and we'll save it. So that's it. If you have multiple files, you can load multiple files in a similar way. So we said that. Now we will go to the destination. This is the log statement where we actually take the input and send it to the destination, which is the Elasticsearch. So before we actually send it to the destination, what we are going to say is parser pattern_db. So that's the pattern_db is the parser that we define, and we're now using the parser function to call that patterndb. So now the Syslog-ng knows that before sending the log to the Elasticsearch destination, it has to use that patterndb parser to parse out the variables or the values. So that's that. Let's go ahead and CTL syntax only, if I remember correctly. Nope. Syslog-ng -- syntax only. So syntax looks good. I'm going to say syslog-ng ctl reload, configuration reloaded. So now back to this guy here. I'm going to now put some more lines into the log file. And let's go back to the Kibana interface here. Go to the discover, or just go ahead and refresh. Do we see any messes here yet? Not yet. I'm going to visualize, back to discover. Not yet. Oh, let me take a quick look here. TB input, tell varlog messages. Nothing that I can see wrong here. Okay, here we go. So we can see, as we can see, there may be some other variations. I don't think so. Because we use the same timestamp, it's really, I could really do that, create a new log event. So because we were using the same timestamp, it got just mixed into the others. So as you can see here, we now have the 3 new tags here, or the meta keys, the sss.result that has the result, the source IP that has the IP address of the source, and the username. So now you can actually like search and filter and pivot and investigate, or also create visualizations based on these tags or the result code. So you can say how many were accepted, right? How many successful logins and stuff like that. In order for this to the index pattern, because we have the new index pattern, you actually go to the management index patterns here, and then refresh index patterns. Now you should see the other indexes as well. Let me do this. So we have 28 indexes. We should see like increase of 3. So yeah, there you go. Or maybe more because of other changes. So now if we go here, we should be able to somewhere here. Okay, now the little warning is gone and we have the meta keys. Now let me go ahead and generate some more logs so that we can use the newest log. Duplicate session here. I'm just gonna log in. Okay, that should have given some log. And I'm going to copy that log actually and put it into our input file. That should really bring this log to the top. Back to the Kibana interface here. I'm going to refresh. And oops. Okay, where'd it go? Oh man. Or we can even say like, filter for value or find anything that exists, right? So there we go. Here are the messages that have the accepted, the result code, the username, and the source IP parsed out. If we remove that as the filter, then we have 14 hits. So we have the mix-up of the non-parsed and the parsed messages. So as we can see, like the Syslog-ng in combination with the patterndb parser can really enhance like how you can make sense out of the log messages. So this is how we configure and use the patterndb parser and actually create custom parsers. We learn how to create custom parsers, how to use the PDB tool to match, validate, create the starter template and whatnot. So that's it for this video. In the next video, we will see how to use the GeoIP database to enrich or extract the GeoIP information for the IP addresses that are available in the log message. I really hope this video was useful. Please like, share, and subscribe if this video was useful, and I will see you all in the next video. Thank you for watching.